Hello, welcome to the first video of this Dissect series. So in this occasion, we're going to start by setting up all the initial guiding curves that we're going to be using to drive the whole structure of our stadium. So to get started, what we're going to do is to grab a couple of reference drawings and place them on our viewport as picture frames, so we can use them as a reference. So of course this is not something you will usually do, as the drawing obviously come after you have designed your project. But in this case, as this is an existing project and we are trying just to reproduce it as similar as possible, we are going to use these reference drawings just to create the basic curves that we are going to need. Okay, so we're going to start by opening our Grasshopper window, and the first thing that I'm going to do here is to place a point at the origin of our viewport. So I'm going to go ahead and do that. And then the next thing that I'm going to do is to reference it into my definition. So I'm going to go ahead and grab a point parameter. I'm going to right click on my parameter and select the set one point option. Okay, so the next thing we're going to do here is to create a couple of ovals to start defining the shape of our roof. Luckily for us, we have already created one definition that does exactly this in our previous tower exercise. So if you haven't done this, you can go ahead and watch the video that is indicated on the video notes of this lesson. I'll wait for you. If you have already done the exercise or want to skip that part, you can simply go ahead and download the definition and only select the portion that we're going to be using. Okay, so here what I did was to create a Grasshopper user object with that definition so I can have it available as a Grasshopper component. We also have a video that covers how to create user objects, so here I'll just make a really fast explanation. Okay, so this is the segment of the definition that we're going to be using to make our objects. So what I'm going to do here is to start calling some cluster inputs, and I'm going to call as much as the parameters of my definition needs to work. In this case, we are going to need 4 of them. Then I'm going to substitute my parameter with this input cluster, so I'm going to start reconnecting all of my components accordingly. And once that I've done this, I'm going to go ahead and create a cluster output to connect it to my join curves component that I have at the end. And once that I've done that, I can just simply select all my definition, and with that selection, go to my edit tab and select my cluster option. This will automatically create a cluster of our definition and put everything into one single component. And then finally, so I can have this cluster as a component, I'll go to my Files tab and select the Create User Object option. Then a new pop-up window will appear where I'm going to set up my component. So here I'll give it a name, then I'll type a nickname for fast referencing on my search bar, and also I'm going to add a brief description of what my component do. And then I'm going to set up under which category tab I want it to appear. And then just to finish this up, I can reconnect all my original parameters just to check our new component is working correctly. Okay, so now we finally have a tool that we can use to create some ovals, so let's go ahead and start setting up the main geometries. So I'm going to go where I saved this component, which in my case is in the My Tools tab, and then under my Curve subcategory, I'm going to have my oval component. So if I double click, you'll notice that I can access this cluster and I can make additions if I want. So in this case, this definition is asking us for 4 variables. The first one would be an initial point to start setting up our oval, and then it's asking us for a couple of radiuses and a special distance. So here I'm going to go back and start setting this up. The first thing that I'm going to set up is my initial point, which is going to be this one we already have here. And then I'm going to go ahead and create some sliders to fit the rest of the information we need. Okay, so here's my slider, and I'm going to set this one up to something like 130, as we're gonna make a big oval over here. And here I just want to remind you, these dimensions are in meters, so you can always switch the Rhino file into whatever dimensions you want. Okay, so then I'm going to make some copies and start setting up some values. So the first one I'm going to set up to 50, the next one will be 100, and the last one I'm going to set it up to 120. Then here I'm going to go to my top view and turn on my reference frame so I can try to match as much as possible the shape of my oval. So here I'm going to tweak these sliders a little bit Here I'm going to type 46, and then I'm also going to adjust these other couple of sliders. And remember, here you can play with these values. The main idea here is just to try to approach as much as possible to our original shape. Okay, so the next thing we're going to do is to create another oval for the top part of our roof. So to do that, we're going to use another reference that we have over here, which is this one. So what we're about to do now is to move this point in the C vector. So I'm going to call a move component. So here I'm going to type move and retrieve this component over here. And then I'm going to connect it to my point. Then I'm also going to call a C vector, as that is the direction we're going to be using. And I'm also going to create a slider to specify how much I want to move my point. So here I'm going to simply type 40. And I'm going to make sure this slider is set up to floating points to have a bit of more precision over here. And then we're going to set the height somewhere around here. Then we're going to go ahead and select this oval component and these variables that we have over here and create a copy of them and connect them to our move component over here. So in this way we have now a second oval at the top part. Now we're going to start setting up some new values for our second oval. So here I'm going to change this value to 39, this one to 56, and this third one to 65. Okay, so right now we don't need to be really specific here. As I just said before, we just need to try to match as much as possible the shapes from our reference images. So here I'm gonna go to my top view just to check our oval looks right, which I think is the case, so we're just gonna leave it like that. Okay, so now we need to make sure that the seam of our oval matches this point. So for example, if I call right now an endpoints component to check the current position of our seams, you'll notice that it is actually over here. So we need to move it so we can have it in this place. So what we can do is to call a project point component. So here I'm going to type project and select this component that we have over here. So the first input is asking us for a point, so I'm going to plug it to our origin point. And then it is asking us for a projection direction. So here I'm going to call an X vector. And as I want to go in a negative direction on this occasion, here I'm going to set my value to -1. And then it is asking us for a geometry to project on, so here I'm going to plug it to our oval component. And now as you can see, we have located a point where we want our seam. So the next thing we want to do here, as this is just a simple 3D point with a normal x, y, z coordinates, is to transform it into a corresponding parametric value of my curve. So here I'm going to call a curve closest point component. And then as our point, I'm going to use this one we have just projected. And as my reference curve, I'm going to use my oval component. So now here we have a parametric value that we can use to adjust our seam. The next thing we're going to do here is to call a seam component, which is this one over here. And again, it's asking us for a curve to adjust, so I'm going to connect it to my oval component and my parametric value, which is going to be this one that we have over here. So then we get as a result the same oval, but this time our seam is located exactly where we need it to start locating all the points at which our main structure columns are going to be located. So to do this, I'm going to call a divide component. And I'm going to plug it to my newly created oval over here. And then here for my number of division segments, I can simply call a panel and put a static value, as I know I won't change this value. So here I'm going to type 65 and make sure that I have selected the multi-line data option selected. So that's it. Now we have located these points which we are going to use to start pulling up our profile curves. And in order to do that, what we need to do here is to create a collection of vectors that go in a perpendicular direction to our curve. So here I'm going to call an horizontal frame component. So I'm going to double click and type H frame and select this component over here. And then this component is asking me again for a curve, so I'm going to plug it to my seam component over here. And it is also asking me for some parametric values, which are going to be these ones. So if we look closely to our curve, you'll notice that we have now some new frames. So from these frames, I can extract only the vectors that I'm interested in. So I'm going to call a deconstruct plane, which is this one. And In this case, we're just gonna need the vectors in our y direction. So the next thing we're gonna do here is to move these points toward this direction. So here I'm going to call a move component. And then I'm also gonna call an amplitude component, as I want to be able to control the distance at which I'm going to move my points. So I'm going to plug this one to my y distance, as that is the direction that we want to use. And then I'm going to add a slider, so I'm going to type here 40 as a starting point. And then I'm going to plug in my amplitude component to my move component. And here I think I make a mistake. This move component must be plugged to these points over here. So here I'm going to increase these values, and what I need to have here is all my points surpassing my second oval. Then what we're going to do now is to create a set of lines between these sets of points. So I'm going to call a line component. And here I just want to make sure that my start points are these new points I've just moved over here. So that's where I'm going to plug my start points, and my end points are going to go to these points over here. Okay, so now we're going to use these lines to create some surfaces which later are going to be used as intersection frames. So I'm going to switch my perspective view so we can see this better, and then I'm going to call an extrude component and plug it into my lines. Then I'm also going to call a C vector, and here I want to make sure that my surfaces are always higher than this oval. So what we're going to do is to go back here and call an addition component, and I'm going to plug it to this height parameter over here. And then I'm going to set a value of 10 or more. So the idea is that I always pass my top oval. Okay, so now as you can see, we have created a collection of surfaces. So the next thing I want to do here is to scale these surfaces outwards. And later you're going to see why. So what we can do here is to call a non-uniform scale component, which is this one over here. And then as my geometry input, I'm going to plug it to my surfaces. And as my reference planes, I'm going to use again these same surfaces. And then here we just want to scale our geometry in this direction. So here I'm going to simply type 1.5, as we just want our surfaces to go slightly bigger to what they are now. So the idea is to have some surfaces more or less like this. So now we need to go ahead and locate another oval, which is going to help us to create our profile curve. So here I'm going to temporarily hide these surfaces. And then I'm going to go all the way back here and call a move component. And then I'm going to go ahead and move this oval over here. Then I'm going to add a C vector, and I'm also going to add a slider over here. So I'll type something like 30, and I'm going to make sure to place it more or less around there. So the next thing we need to do here is to make it slightly bigger. So we're going to scale it up just a little bit. So the first thing is to call an area component, so we can use the centroid as our reference plane to scale it. And then I'm going to call a scale component. Okay, so I'm going to plug it to this oval we have just moved over here. And then I'm going to use this point as my reference plane. And for my scale factor, I'm going to use a really small number, something like 1.02, as we just want to make our curve slightly bigger. Okay, so something like this looks okay. So now as you can see, we have a collection of 3 ovals, which we're about to start using to create our main profile curves. So the next thing we need to do here is to detect the intersection of these curves with these surfaces we have created over here. So to do that, I'm going to call a Beira curve intersection component, which is this one over here. And I'm going to use my surfaces as my intersection Beiras. And then I'm going to use this curve to find these intersections. And then I'm going to use another intersection component for my oval at the top, which should be this one over here. Okay, so now we have those intersections as well. So now I'm going to hide these surfaces, and also I'm going to hide these lines over here. And now the next thing we're going to do is to use these intersection points to create some interpolated curves with them. So here I'm going to call an interpolated curve component. And the first points that I'm going to be using are going to be these ones that we have over here. But the problem I think we're going to have is that all these points are in one single branch. But if we go ahead and look for these ones, you'll notice that each point is an individual branch. So we can easily solve this by calling a graph component to place each point in an individual branch. Okay, so now these are going to be my first point that I'm going to be using. Then I'm going to use these other points over here. So I'm going to press my shift key and plug them over here. And finally, I'm going to use these other points over here. And now, as you can see, we have started to define some profile curves for our stadium. So now we're going to go ahead and create another set of curves to define more our main profile curves. So before we start with that, I'm going to show you a small representation of what we're about to do here. So while designing a project like this one, there may be many constraints or structural logics which can be applied to drive our design. In this case, we're just trying to reproduce this design. I have just come up with one. So remember, there are always many paths to achieve something, and what you end up doing at the end is always determined by special conditions of a project. Okay, so now as you can see, what we have is an interpolated curve that is being created by 3 intersection points. So the next thing that we're going to do now is to create a line from the start and end points of our interpolated curve. And then we're going to go ahead and find the middle point of this line. And we're also going to locate 2 points in our interpolated curves by evaluating it with 2 parametric values, more or less what I'm showing you in this image. And then we're going to create 2 vectors going from the points in my interpolated curve to our middle point. And then the next thing that I'm going to do is to move these points along those vectors, which then are going to be used to create another interpolated curve. Okay, so now I'm going to select everything that I have here and group it together by pressing the Ctrl-G keys. And later you're going to see why this is a good practice. Okay, so next what I'm going to do here is to call a curve parameter so I can start treating all these parts separately. And the first thing that I'm going to do here is to make sure that I reparameterize this curve, as I want to make sure that the domain of each one of my curves goes from 0 to 1. So here I'm going to right click and select this reparameterize option. So now, as we saw on the previous slides, the first thing that I'm going to do here is to call an endpoints component. And then we're gonna go ahead and create a line from this component. So here I'm going to call a line component. So once we have created these lines, the next part is to find the middle point of them. So what I can do is to call a point on curve component. And here I'm going to leave it in 0.5, as that is the exact middle point of my domain. Then if you remember correctly, the next thing we have to do here is to find a couple of points in this interpolated curve. So to do that, I'm going to call an evaluate curve component. And then I'm going to call an slider so I can start setting up a value. And as you can see here, we have a point displacing at our interpolated curve. So now we need one extra point here, so I'm going to simply go ahead and make a copy of these ones. And I'm going to move these ones almost at the very end of our curves. Okay, so the next step is to create a vector that goes from these points up to our middle line point. So what we can do to create this is to call a 2-point vector component. Then I want the start point of my vector to be these points that I have over here, and the end of it I want it to be the middle point that I have over here. So then I'm going to go ahead and do the same for the other one. So the last part we're missing is to move these points toward these directions so we can then create some interpolated curves. So I'm gonna call a move component and plug it to these points over here. And as my vector, I'm going to be using these ones over here. So here I'm going to call an amplitude component so we can control the distance. And then of course I'm gonna add a slider over here and I'm going to type the number 10. And I'm gonna make sure that these are set to floating points. And I'm going to set this one to 7.65 or something like that. And then I'm going to do the same for the other point. So I'm going to select these 3 components and make a copy of them. So then I want to move these points using this vector I have over here. And I think this value needs to be much more smaller. So here I'm gonna type 3.27 or something like that. Okay, so we have finally identified these points. So now we're just missing our interpolated curve. So I'm going to go ahead and hide some of these guys over here. And then I'm going to call an interpolate curve component and start selecting the points that I'm going to be using. So my first points are going to be these start points I have here. Then the secondary curves are going to be this one that we have over here. Then we're going to use these ones, and finally we're going to use these endpoints over here. So there you go. Now as you can see, we have some secondary profile curves. And as you can see, we have started to define the overall shape of our stadium. So on the next video, we're going to cover more aspects of geometry optimizations by doing a little bit of scripting with the Grasshopper Python component. And I think that will be all for this video. So thanks a lot for watching and see you on the next one.